Welcome back. At this point, you should have Operation 1 finished. Operation looks like this after it's machined. Let's take a look at it, rewind this, so we can see our procedure. First, we're going to do a face mill cut, then a center drill, pocket, circle interpolation, contour with depth of cuts and multi-passes, chamfer, engraving, and it produces our first part. So this is what we're looking to finish our first operation. Now we need to flip it over and cut from the other side. So this is the material we need to remove when we flip it over. A couple things we'll do. We'll set up a soft jaw that holds this profile on this side. Our Z0 will be at the bottom of the part. So when we fly this cut off, the final Z should be the thickness of the part of our drawing. So our Z should be 0.625. Let's get started. I'm looking forward to what we're going to be doing and learning the beginning of what we call WCS, World Coordinate Systems. And this part is a 2 operational part. Let's get going. As we get started, there's a few things I would like you to take a look at, if you remember, is our work offset. Our work offset was in quadrant 4, our part, and our origin was X was in positive, Y was in negative, and Z was at the bottom of the part. I think you guys have a strong understanding by this time and what I mean by going off the bottom of the part. All of our top of the stock is what we have for material here. If we come over to the tool manager, this is very important. What I want to go over a few steps on here. We want to make sure we're using the generic Haas 3-axis VMC. Our first tool path that we did was a facing with a 3-inch tool. The geometry we used to do the fly cut was the stock boundary. And if we look further into this, it gives us more information. Let me span this out a little bit more. It gives us the name of what we used for machining the first operation and the program number. As I go further with this, I think file management is probably going to be your best tool in the future that you use. I look at the name of my NC code that I did this, speed handle with 7-inch jaws with 6.88 Kirk vices and 2050_2.1 doesn't make sense for this part. It made sense that I was explaining everything I was using on it, so I did save the file as such. But I want to be more specific with this. I want to call this, let's just say speed handle operation 1. And then when I do the second operation, I'll call it speed handle op2. And the program number for this op1 is 4000, and the program number that I'll use for op2 would be 4001. Trying to organize everything I'm doing. So let's go ahead and learn how to do that. First thing we want to do is make sure everything's selected. We come over here to Tool Groups, right button mouse click on Tool Group, and up here we have Edit Selected Operation. First of all, let's rename the NC file name so I can change it. Right now it's that big list of words that I have in there, so I'm going to delete some of this, delete a little bit more, and I want to call this Speed Handle Operation 1. I usually use op for my operation, and this is what I'm going to call it. Now, as you can see, if I expand this again, now look how much smaller this is, and it defines more what I'm doing with the part. Speed handle op 1. Okay, so again, we click on we choose all the files, so each file will have that same name and same program number. Right button mouse click, edit selected operation, and change file name, and it changes them all to that name. The next thing we want to do is make sure our program number, change, edit selected operation, and our program number is 4000 for all of them. And if we look in here, 4000 is the one we have for it. If I expand number 5, for instance, it's 4000 with a save NC file name. So let me minimize this. Now also, it looks like right here we have a tool group. And in the groups, we have these here. We have machine groups. I can add a lathe to this, a router, but we're staying the same. This is not what we want to add to it. We don't want to add a new tool group yet. We will get back to that. But getting familiar with right button mouse click, we're going to get all these different menus. I actually want to rename it. What would be a good name for this one right here? I would agree with that too. Speed, handle, op, 1. Why not the same? It defines all this information right here. Will machine, that whole tool group is going to machine just the operation 1. So if I wanted to see that again, I can. And if you remember from the other video, we saw that if we choose verification, we look at our part here. I'm going to speed this up a little bit. It will actually machine out our part. And there it is, engraved, chamfered, and everything. I turned off my tool so it'll go a little bit faster. I could turn it back on too again, so don't be surprised with that. I'll minimize that. And now we have our information. That is very important. Okay, let's continue on with operation 2. First thing I like to do is set up my group for it. So I'm going to come up here and select on machine group, right button mouse click on my mouse, go to groups, and add a new tool group. This new tool group is going to be called speed, handle, op, 2. And so all the toolpaths I do for this is going to be underneath this tool group. Very good. Now, the idea of doing this is I want to be able to set up my part that it will flip itself over so I can machine it. So what we're going to do basically is I want to take this part here. I'm going to hide everything else, and to hide something that what's selected, to hide it on the screen, Alt-E. And what I want to do with this is flip it over because that side's been machined and machine it from this point on. I chose that flipping. It could be flipped any way you want, but I'm going to choose this way. But here's the key thing. I want the bottom of the part, oops, slow down there. Bottom of this part, right at that corner in the middle, to be my XYZ0. So that would be from the bottom. So if I come to here real quick to the planes, and I choose bottom, WCS, okay, and I hit my G view to the bottom, that's the way I want it to look at. So Alt-S, you can see the part, and so on. I turned off the text when I just chose the solid, so I want this to be my origin. Let's go ahead and try that real quick. So I got a position in the bottom where I want it. It really doesn't have to. I'm going to go back to isometric up here. And now down here at the bottom it says top. I just know that if I look at this, that's the way we originally machine it. I want this corner right here upside down like that to be my origin. So it helps out if you get it kind of positioned to where you want it. And a good way to do that, I'm using a 3D mouse right now to rotate it around. If you don't have a 3D mouse, a little secret here, you can hold down Alt and hit your cursor arrows to where you want it to flip it over to give you an idea. It's probably the easiest way that beginners can use, or you can use your middle mouse button to spin it around as well. See how that works? The middle mouse button. Sometimes a lot of beginners can use the Alt key, holding it down while you touch the cursor keys and play with it till you get it to where you want it. So I'm just going to get it set up to where I want it. That looks good. I'm going to set up my WCS now. So let's go ahead and continue with that. So what we're going to end up doing is we're going to go to WCS down here at the bottom, Plane Manager, and a dialog box appears with a lot of information. We're going to stay in the basics of it now. The first top was all designed and cut under top. We just started with the top. The C stands for construction plane and the T stands for tool plane. Okay. And then the last one over here I want to emphasize is your work offset number. And that's where we're going to get into this part too as well, because our first operation is done in a vise, and we want to do production. And so we're going to have a second vise set up, and we want to call that our work offset vise. That's number 2. So work offset number 1 is G54. Our second vise will be offset 2, which is G55. So I need to set up a whole new work coordinate system for that. So I am using solid right now. So there's many ways of doing different ones there, but we're going to use solid in this beginning class. So I choose solid face, and I come down here and I choose my solid. Now there is my gnome. It shows X, Y. Now it gives me 8 choices of planes that I can choose. What I really want is Z going this way. I want my X to go this way, and I want my Y to go up here. So that doesn't look like the one I really, truly want. So let's take a look at this. I'm going to go to the next one. How does that look? Well, the X isn't going the way. If I was to machine this, then in my vise, I would have to have it laid out like that, which is not very strong. So we're going to go back here. Let's try the next plane. And if we look at this plane, we got X going this way, Y going that way, and Z going up exactly where I want it. So I think the choice of 3, now it may not work the same on yours. It may be different, but this is the layout. We want the small hole to be over here on the X side, the large circle to be on the minus X at this point. But then we're going to take that gnome and put it down here at the midpoint of this arc. So I'm going to select that as the layout. I choose the plane. And from there, I'm going to call this, what good name should we call this? That we've been following a sequence of operation. Very good. Speed, handle, op2. So not only that the tool group defines this new plane, it also defines our NC name. It's going to define our NC name, and so on and so on and so on. Okay, so that's good right now. We could use these buttons right here to reset it, but I'm going to choose the main menu. I just want to set this up. Right now, it believes that that's my XYZ0 at the top of the part. We don't want it there. We do want it here, so we have one more operation. Let's just set this up and say OK. And as you can see this, it's exactly what I want. That's my new operation. So, but I'm not done with it. It's highlighted right now. And I want this to be my construction plane and my tool plane. So by doing this, I can hit equal, and it says, hey, now this is your construction plane. But that's still not where I want my Z. I like the layout of the X, the layout of the Y, but I want the origin down here at the bottom. And we're going to use this selecting key button right here, the selection arrow. When I choose this, it's going to ask me select point for construction plane origin. Well, where do I want that? I said I want it to snap to the midpoint of that arc. And now look where my origin is. You can kind of see that it's exactly where I want it. At the bottom of the part, it's down the middle of the part, and it has my Z at the bottom, my X, and it's cutting in quadrant 1 and 4. That is perfect, and it changed my information at this point. My X and my Y and my X has also been changed. So when I select equal, it says now, oh, you want your whole new world coordinate system set to this operation too. It actually flips the part over. It sets up a new XYZ, and as I choose this, I hit OK. I go to the top view. Now watch this. This is neat. Top view. It is laid out this way now. So you can see what it's doing. It's giving me my X and Y. Now, the other thing is I need to define that. So on the next step, setting that up was pretty easy. Remember, WCS, planes, solid face, select your plane, equal your construction plane and tool plane, and choose your new origin if needed. Check. Let's continue on. Let's continue on. Now, if you hit F9, you can see my new origin here is my X running this way, my Z's running up, and my Y is up on top. The part is resting in quadrant 4 and 1. My Z's at the bottom, as you can see here, at the very bottom, and it's all set up for machining. But the one thing I want to make sure is when I machine this, that it is G55. Now this is very important to watch. So as I look at this, the last one we left off, we went to WCS, plane managers, and we set speed handle. We chose this distance, what relates to that origin there. But the key thing is when we post this, we want this to be work offset 2, which is 55. Now, as of now, the work offset dialog box up here, it shows no work offset, so it defaults to G54. We want to see a work offset set in this value here. And how we do that is we come down here to work offset number, and we're going to call it work offset 1. Now, the thing I try to explain that work offset 1 is 54, which is true, and work offset 2 is 55, and 3 is 56, and so on. But by 54 plus 1 is 55, and that's what we add here. So if I was to put 1 in here, G54 plus 1 is G55. 2, G54 plus 2 is G56. G57 is 3. 4 would be G58. And the last one, G59. But the Haas has plenty more offsets, and that's for another day. So I want to give it 1 offset. When I hit enter, you can see it's adding 1 offset to the 54. I hit equal. Now, make sure, and then check. And that, when I do toolpaths now, like this one, when I post this information, it is G54. Work offset 1 automatically. For instance, if I was to post this, just to give you that point, I'm going to G1 it, just the face. We'll take no. We're only going to check the first. And I just want to bring up the first one as fast as possible so you can see that in that heading, it would say G54. So as we come up here, you can see right here, G54. Now everything after, in the new tool group called Work Offset 2, this will be reading 55 for my other toolpaths on the flip off. And then that would work out for our second operation. I'll shut this down. I'm not going to say save that. Now let's start down here. Let's move the arrow down below here so we do all our toolpaths here. This I can shut down now because we already completed that. I'll set myself up here, Alt 1 to see the top view, and Alt 7 to the isometric. And as you can see, it reorientates itself to the new world coordinate system. I turn the text on so you can see we're from the bottom side, and our text is backwards and looking at us from like a behind scene. So the first thing we want to do, since we have this set up, would be to face the part. Very good. So we're actually going to use the same strategies here. So there's only a couple toolpaths we can do in here, and that is face, chamfer, and engrave if we add engraving. Okay, so let's go ahead and continue on. I'm going to go to toolpath again. I'm going to choose face. There's really no stock to set up, but I'm just going to say okay because there is stock from the first one. And I'm going to go to tool. We're using tool number 3 with the same settings. We're going to use 1 pass with the same settings. Depth of cut. Are we cutting at 7.4 the original? No, we're not. We're setting up a new one, and our new depth of cut will be here at the corner, at the top. So that should read 5/8, 0.625. Our top of stock, we do start at this level here. But one thing I want to mention, we can take that in 1 pass because this is probably over 1/8 of an inch. But let's add some depth of cuts to our shell mill, and we'll go 60 thou, 0.0625 per pass. Depending on the horsepower of your machine, it's really important that you be careful of how much tool engagement you have here. We want to make sure coolant's on, which it is. And now we can hit OK at the end of this. Put this back over here so I can see it. There we go. And hit OK. And now that gives me 3 passes to cut through there. And let's take a look at this. Let's go back plot. We'll run it. There's our first pass. It's going to remove some of that material that we were holding before. 2 passes. And 3 passes. Now, if we only wanted 2 passes, what will we do? We just increase the depth of cut. This is good, 3 passes for now. Okay, so we have our our fly cut. Now, what's going to be neat to see what we have here is to go back and select all, verify, and it's going to show the first operation because I selected a 2, which is on this side. And then it's going to come back and show the back side. So let's do it upside down so you can see this. It's going to go through the whole process of cutting the first one. And this is our first fixture. I'll make it translucent. So it's machining that side there. And I will come to a stop right here. Slow down the speed so you can see what it's going to do. And as we come over, it's going to slow down. Do my engraving. And it's almost done. And I'll stop it right there. I'll jog this up to our next operation. I'll slow this down. I'll make it solid again so I can see it. And now, as if we stopped the program here, took the part out of the vise, put it in our fixture for the flip over part, we run this, and it'll come in, pass, pass, and there's our part. This is what it's going to look like while it's held into the jaw, and I'll have a demo for that down the road here. But we can engrave on this if we want, and we can chamfer it. So the next thing we need to do is chamfer this side. Now that we have the facing done, we can do the next step, which would be chamfering. But before we get into that, I want you to come back over here to this area here, because this is probably one of the most important aspects of what Mastercam does, and it organizes its toolpath through different types of methods of toolpath or titles of toolpath: peck, drill, pocket, contour. Well, we're using facing 2 ways here. Now, in doing that, we know that we want to transfer this part to another soft jaw of some sort, but we don't want it to be the same name or the same program number. So we want to change that. And again, let's take a look at this one. It says it's speed handle op1, which it isn't. Clearly, it's op2 and program number 4000. We can't have the same program number for the same part unless they're combined. So let's go ahead in this beginning step before we continue on. As we did here, we would do the same thing here in changing this to speed handle op1 and program 4000. We're going to change this to what? Speed handle op2 and program 4001. By doing that, we're just going to select what we want to change. And I'm going to right button mouse click on this, edit select operations, and change the name first. Well, it's set to op1 because it uses the one prior to it. So I'm going to change it to op2. And as you can see, it changed here. I'm going to right button mouse click on this again, edit selected operations, change program what? Number, and call it 4001. Now I have 2 programs I can send over there. Realize in production, we would just have one program name. And if we're using the shell mill, we'll use the shell mill on both vices. This is a beginning class where you're going to do your first operation and understand that. You'll build a second operation and run 2 programs. And later on, you'll see how to blend those together and run production. So you're constantly running 1 op, 2 ops, 1 op, 2 ops. And when it finishes the second op, you have a product. So let's continue on with the second operation. So our triangle's down in this area. You want to make sure that's where we're going to do the next toolpath. We're going to come up here. We're going to do contour. We're going to choose solid selection. And we're going to choose the face. And we're going to choose this face. And as you can see, that it's already set my direction of chain, counterclockwise inside geometry and clockwise on the outside. Check. The tool we're going to use, since we've already used it and it's in our carousel, we're going to use number 6, the 3/8 spot drill. Correct. And we're going to set this down to 2000s chip load. We're going to run this at 3500 and then 2000 chip load. Got to set my spindle speed first. And our plunge rate will be 6 inches a minute. Okay, so this is a good feed to get around there. It's a good beginning. We're not looking to get high production stuff, so that will be in another day. Then we're going to go back here to cutter comp, make sure this is correct. And we're going to do a chamfer on this one. So I want to change that to computer. Contour type, I want to choose chamfer. And the width, just like we did the top, is going to be 25 width and tip offset 25. And it'll give us a clean 25 thou chamfer. We can turn in, lead out if we wish. I like to leave these small numbers, copy them over. I don't go big. It's a lot of waste of time at this point. That's correct. And then the last thing we want to do, link in parameters. Now, look at our depth. It's exactly where it is because we selected that in space. And one of the neat things, we can always calibrate our tools based off this too. So if our shell mill cuts this part and let's say if it cuts it at 625, what had happened to that shell mill? Well, the calibration of that shell mill needs to be increased by 5 thousandths up to be more accurate. And so in your wear, you can add 5 thousandths so you know the next part you run will be right at 6.25. Good quick way to understand that when we machine from the bottom of the part, our Zs are going to be positive, and our Zs on the second operation will be to the spec of the drawing. So if the thickness of the part always says 1 inch, and this says 1 inch here, when we cut it, we can measure it. If it doesn't cut to 1 inch, then that tool needs to be calibrated. So the top of stock, since we removed with the shell mill prior, we're going to change this to 0.625. And everything else looks good. We check our coolant, it is on. And at this point, I have my second toolpath. But here's something important I want to show you. Right now, it kept the name, but it did not keep the program number. One thing that we have to understand, the name is what keeps these together. The program number doesn't keep them together. It just is it's put in at the top of the program under the O word, the operation or the program number word, but it will always take the first program number when you post it. I hope that's clear. In other words, if I group all these together, it will be 4,000. For instance, let's go over here and I'm going to G1 it. I got the 2 selected. Operation, because it's picking the NC file name. And remember, there's one program number here is 4,000 and the other one is 4001. So let's say save. What groups it together is the NC name, but as you can see right here, the program number takes the first one no matter what because there's only one place to put it. But me being me, I always like this to have the same program number. So when I'm all done, I like them all to read 4001. And you should save at this time. Now, since we're back on this file information, we want to take a look at this parameters, work offset ones. What does that mean? Well, let's take a look at this facing. It says parameter and there's no work offset. Remember when we were back at the WCS and we went to plane manager and we told it to add a work offset to it. So this work offset has changed the makeup of this one and as well as this one. In fact, while I'm on in this WCS, anything I toolpath will be work offset 1. But the key thing is I'll select this one here. Let me select phase here and phase here, and I'm going to get 2 files. I'm going to say the first one's going to be, I don't want to choose all the operations. There's op1, and then it's going to come up and it say, do you want to, no, I don't want to choose all the operations. There's op2. Now I got 2 files that I posted, both facing, both different operations, both different work offsets. They will come up, and here's the code. Here's the 2. I will view them horizontally, or vertically, excuse me. And here's op2, here's op1, and we were talking about the work offset. So op1 has G54, and the work offset for the second op would be what? G55, correct. And the G codes are pretty much the same, except the positions here. One of the neat things is, as you can see, running in positive, when we shell milled or fly cut it, or face cut the part, it was 7.4. When we flipped it over, our final cut was the thickness of our blueprint. And that's the way I like to machine, because if my Z is exactly what my blueprint is to be the thickness of the part, I can measure that and I can adjust that. I hope you can relate to that and how we see these values that are absolute and not just always from the top of the part and trying to calculate and figure out what we have to go up or down or whatever. This is absolute number. Absolute programming is the best and the easiest way to interpret G code and calibrate your part to be to spec. Let's continue on. Well, now that we're basically done without any custom engraving, which I'll leave that up to you, one requirement I do ask you is you do sign your name wherever you like on any of these areas and come up with one more graphic here. I will offer one tomorrow in class, and hopefully you would come up with it as well and use that. Okay, so here we go. We got our first op, we got our second op. Let's verify this now. And look at, there's only two ops without the engraving. The only thing we have missing here is the engraving to finish it off. But let's go ahead and verify this part. I'm excited to look at this because it's going to be our finished part. I'll speed this up. And when it's cut out of this block of material, this billet piece, this solid mass of material, we're actually going to produce a product. This is one of your first biggest products that you're going to do, and it's a double operation. Our next part is going to be 5 operations, and I believe once you understand WCS more, you will be able to flip apart any which way you wish. So let's go ahead and continue on. And let me make it translucent because it's cutting the first op. As it goes on, it's doing its contour and it's going to do its engraving. We'll slow it down there. Now we're going to bring it down and we'll play. Oh, it already cut me up. So let's back it up. I'm going to have to rewind it because I wanted to stop it there. So let me just advance it to this part here. And we'll play it. Now watch this. It's going to come over here. It's going to face, and chamfer our other side where it needs to. And we have a finished product. I hope you find this exciting. I do. I don't think it ever gets old. I believe that manufacturing and education will get you further in life. And I'm thankful that you guys are in the class right now and understanding this process of machining. Actually, what I like to call it, digital manufacturing. Let's get out there and cut. These are your chips to make, not mine. And I'm just thankful you're in the class. I'm adding this little segment. It's more of an advanced process of it. If you draw your vices in your CAD system here, you only really need to use one offset. And that's what I like to do. So you can use still 2 offsets if you want, but I can actually program this using 1 offset and not having 2 offsets. So if I come over here to WCS, just to show you, did a work offset here, but I'm going to do equal the top. Okay. And that's all I'm using. So I'm just using this offset here. Now, to show this information, this chain is based off this. If I come over here and say, hey, I want that same chain, this is advanced, remember, I can go to my parameters, go to my WCS, go back to select the plane I want to, which is the top, copy the top over, check, make sure this one, plane, can't remember, we'll go top, regen, now regen all, sorry. And if I take a look at this and verify it, watch what happens. This part will cut that one. You do the whole process of it. And this is more for production, just to show you. I'll explain this more in class, but I wanted you to see that if I have my environment drawn out, it's doing the other part too well, using only 1 work offset, which is G54, which is my world coordinate system. All I have to do is cut the vices to match that, put them in there, and I'm doing production. And if you want to see this, I'll do this a little bit more advanced. I would take this one, move it after facing. By moving it after facing, tool chains. And then this one, the chamfer, I'll put it down here with the chamfer too as well. So as it has the tool up and runs the chamfer, now it's running both of them. And let's watch it different now. So I'm more efficient when the tool changes to that one tool. And we can look at it here. Here's my materials. Here it's laid out in 3D space. After it's done first one, you can see this is what it looks like. We flip it over on the jaw. And I go ahead and hit run. Facing. Center drill. Drill. Move this in. I'll speed it up just a little bit. It's going to do the contour, then it comes back over, the chamfer, then it comes back over there. So if I design and develop my environment, basically, I have this information set up the way I want it. In my machine, one offset, it knows the height. When I play this one, it will be 0.625. The jaws are cut all at Z0 at the bottom. This one right here, let's hide this one right here. We'll take the invert, Alt-E, and you can see I have my cut in that jaw. I forgot to select the text, but you can see that's the shape I'm going to have in the jaw. It's at the bottom. That same depth, Z0, is the same as this depth here. Let's take this, invert again, Alt-E, and get rid of that. And you can see that depth there is Z0, and this depth here is Z0. But now, rather than doing a G55 work offset, this is my environment. My origins here. I drew my vise exactly where it's on the machine. I cut here. It knows the distance from here to the cutting of the part. It knows the distance from here to this cutting of the part because it's using one offset, and it makes it a lot easier for me so I don't have a lot of offsets that I have to build. But this is more advanced. Again, it's kind of neat to see that if I was in production, I wanted to run these, I have two vices, and I wanted to produce them all day, I wouldn't even have a second operation. I would call it a second operation, right? You see that? But that's important now because if I post this, I'm still going to get two files. So what I have to do, remember, it's the what? It's the NC file name that defines it. And I forgot to change this one. So let's go over here and we'll just go like this. Right button must click on here. Edit, NC file name, and I'm going to call this speed handle. Whoops, let's get rid of all that. And I just call it speed handle. Speed handle. And that's it. Because that whole operation is a speed handle. It's one toolpath. Now when I NC this, okay, NC it, it's all G54. And it's just called speed handle. So when I run this program, I have two parts in there and start my production. I run it, it finishes, it's done. This is more advanced because I'm keeping the tool engaged. There's G54. Let's go to the next. Next. Here we go. There's tool. Look at that. Tools, G54. 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 And G54 again. So you can see as we go in here, it's going to use just G54 for the whole thing because I drew it in 3D space and I set up my environment in my CAD system. Digital manufacturing is the way to go. If you can relate your envelope of your CNC machine, you're going to have what I call a complete understanding of the relationship between CAD and CAM and never crash into tools. Hopefully. I still do. I think we all do. And that's what's fun about it. But we control our first operation. Once we know we have production, we continue on. I thought I would add this little section to show you how exciting it is. I will show it to you in class. But to understand this and lay it out, it's all about CAD. Now, if you're creative enough to take these vices, copy them over. I think I did them 15 on center. I'm not too sure if it isn't. If I move it, it regenerates my tool path, and I'm okay with that. Well, let's get to work.